Good morning, everyone. Thank you so much for joining me. I would like to say it's very nice to be in Poland, but unfortunately I'm not. I would enjoy to be there with you all and enjoy the conference, but unfortunately these are the times that's here. As was said, my name is Paul Stack. You can find me on the internet at Stack72. I work for a company called Pulumi, and today we're going to be talking about infrastructure as software. It's very strange that my track is in the .NET track, but it's perfectly related to the types of things that I'm going to show today. So we understand that lots of different people and lots of different companies are now on the cloud transition path due to current events that's happening in the world, due to COVID, all these different situations. There are a number of people starting to look at being able to operate more in the online world and be able to use the cloud in order to do that. Now, there are different types and different variations of the transition that's going on right now, but there's very much a journey of how people are approaching the cloud. So sometimes you can have companies who are very much like a V1 style architecture. And what I mean by that is that they have end-tier architecture in the cloud. They had it in their data centers. They've picked it up and they've moved it directly across. So they have application web servers and they have database web servers, and then maybe like a load balancer that sits across the top. It's like a much more traditional style operations architecture, and the machines are probably a lot more long running. They're not ephemeral. And that usually means that companies are taking advantage of a tool like Puppet or Chef or Ansible or SaltStack in order to actually be able to manage those machines that are running in a long way. Then you have companies who have moved a little differently in the way, and they've actually gone for a wee bit more of a transitional style architecture. So you have a mixture of maybe containers and VMs. They're taking advantage of some services like, possibly Datadog, a New Relic, something that is like online. It's a SaaS-based product that they can actually integrate as part of their system. And they're starting to experiment a little bit more in the system that's going on. And then you have companies that are starting to build this new wave, this what we at Pulumi are calling this modern cloud architecture. And we think it's much more of a fully dynamic based architecture. You've probably heard words like cloud native and SOA and all these different pieces and microservices. And we believe that this is the style of architectures that a number of people are starting to take advantage of. So you're possibly or more than likely using like a container orchestrator. Think of something like Kubernetes or HashiCorp Nomad. You're definitely taking advantage of storing data in like external storages like S3 or Google Cloud Storage or Azure Blob Storage. You could be taking advantage of functions or serverless or all these different pieces. Now, it's not a specific journey from V1 to V2 to V3. You can, of course, mix and match all these different parts and these variations, but of course, your tooling actually has to reflect what you're trying to talk to here. Now, traditionally, tools in this infrastructure as code space have targeted V1 and V2 style architectures. Pulumi we are trying to build a tool that enables the V3 style architectures by default, but will of course touch that V1 and V2 architectures. And the other tools in the space are traditionally V1, V2, but allow V3. So we're approaching the same problem space, but from a different side of what's going on. Just to bring everyone up to speed of what like some of the terms that I'm using today is, I'm going to talk a lot about infrastructure as code, and just infrastructure as code is like eliminating the manual ways of doing things in the cloud. Do not open your Azure portal, your AWS console, your GCP console and click around. It's actually like codifying what you're trying to do. That allows you to gain visibility in the previews and through code reviews. And of course, it can be automated, it's repeatable, it's immutable, and it's much faster and it's safer, predicted going to market. So infrastructure as code is a thing. If you take one thing away from it today, then please take away that you should spend a little time looking at your infrastructure as code. But at Pulumi, we actually believe we're now in the era of modern infrastructure as code, because Pulumi uses languages. It doesn't use DSLs. It doesn't use YAML. It doesn't use JSON. I apologize. I will rephrase what I'm saying. Pulumi uses traditional programming languages, not the YAML or the DSLs or the JSON in order to do things, which allow you to start to integrate that as part of your normal current workflow. So your IDEs, your testing, your refactoring, your pull requests, using all of your favorite tooling that happens. You can you package things up, you can abstract them correctly. And then once you've actually got the code correctly, you can deploy it using the CLI, which all the tools have a nice CLI for your dev and your operations familiarity. You can integrate it into your CI/CD workflow. And of course, you get all of the audit changes that come off the back of it. So where we differ is in the main step, which is the creation of the code. And then we follow the same deployment and observability principles as all the other tooling. So as we're starting to like integrate much more in a dev workflow, we're starting to believe that this is infrastructure as software. So we're really starting to encourage the use of things like semver, testing, code reviews, pull requests, packaging, APIs, all these different things in order to understand what is actually going on and what people can actually start to build their infrastructure against. And I'm going to show you that as we go through. So Pulumi's got a number of layers to it and a number of ways that you can actually build things. So right at the bottom, Pulumi is actually built on a foundation of providers. Okay, so we have providers that allow you to talk to all of the major clouds, a lot of the major SaaS products in the world, like Datadog, New Relic, Cloudflare, New NS1, Azure DevOps, a lot of different things, and of course, Kubernetes. Now, based on the providers, you can start to build your libraries. You can actually build cloud-specific libraries that you can wrap up common functionality that developers or operations people have to write once. They can package and they can actually reuse that code throughout your organization. And then based on those patterns and libraries that we're actually seeing right now, we have developed this idea called Crosswalk, which we're starting to bring common best practices for using some of the clouds into motion. So if you are familiar with AWS and you need to create a VPC in AWS, then you understand that it needs a VPC, it needs subnets, it needs an internet gateway if you have private subnets, it needs route tables, route table associations, and all these different pieces. Now, Pulumi have been able to wrap that up in a single line of code that we can actually, every developer can actually simply build their own VPC and it is part of their developer workflow. So we're starting to take advantage of some of the usage of the language style ecosystem in order to wrap up and do everything that we're doing. As it's code, we can deploy from anywhere to anywhere. So it hooks into all source control. We'll talk about the languages in a little bit. It hooks into all the CI/CD pipelines. And of course, it will allow you to talk to any environment that we have a provider for. Now, even though Pulumi is code, or what we call code, it is a declarative syntax. So it will have resources that you declare as coding constructs, and it's very much an end state of what you actually want your infrastructure to look at. So on the right, you will see that you're going to create a security group with open ingress ports of 22 and 80 from the world. You will create an EC2 instance of the type size where the constant is declared, where an AMI is declared, with tags and a VPC security group ID. So it allows you to do that, but as you start to refactor code, you can then take advantage of coding constructs. So here you will see an if statement, which will only set public subnets if it's necessary. Then based on those subnets, using the variable public subnet CIDRs, we can actually loop over using a split and a map in order to create a subnet. So as you don't have to start in a very programmatic way, but you can start to refactor your code and move in a programmatic way as you go through it. It has multi-provider workflows that allows you to mix and match different infrastructures all within the same application. It allows you to package things up. So inside Jenkins.cluster, here we actually are declaring some resources that the users of Jenkins don't really need to care about. They just need to understand that you just declare a Jenkins cluster. And then, of course, because it's code, you can step into the API if you really want to go and have a look at what it's doing. We allow advanced orchestration. So this is where things start to get a little more interesting and we start to differ from some of the other tooling. Because it's an imperative application, we actually work our way down the application and we start to be able to do a lot more interesting things. So here we're actually deploying 3 replicas of an application to Kubernetes. When we're finished with those 3 replicas being deployed, we then talk to Prometheus to check the application metrics. When the application metrics come back from Prometheus, all correct and everything working as expected, we continue the rest of the rollout of our replicas. Now, this is possible because if you are writing if you're writing a Pulumi application and it is writing in a language, it is written in a language that has existing SDKs or APIs or tooling that you can talk to, then you can just ingest that code as part of what you're doing. Here, the P8s class right at the top actually wraps some code which talks directly to the Prometheus API, actually pulls some information from the API and checks the values. And once everything works as expected, it will return as you need to. So this is not available in traditional tools because of the fact that they don't use the underlying language ecosystem themselves. We allow very much test-driven infrastructure. I'm going to give a demo of this today, where you can actually mock the responses from the cloud, the requests and the responses from the cloud, which means that you can develop your infrastructure even without any credentials on your local machine, which makes a much faster, tight-knit loop as what developers are used to in building their software. And most importantly for me, because I try and be security conscious as I go, Pulumi has a secrets engine actually built in, which will allow you to secure your secrets as part of your code as we run through, as you're starting to build your application. Anything can just be declared as a secret. And because of that, Pulumi will then keep that secret going the whole way through our engine. Very briefly, to talk about the architecture of Pulumi, because this is some important things to see. Pulumi is a client-based system, so you will have a CLI. The CLI will run either on a local development machine or it will run in a centralized area as part of a CI/CD workflow. And the CLI does two things. Firstly, it will actually create requests. It will make API calls on your behalf to your cloud of your choice as part of your application using the credentials on that local machine. When it creates the resources in that specific cloud, then it will store the state in the Pulumi SaaS. Now, this is storing Pulumi SaaS by default, okay? You can turn that feature off and you can actually switch to storing your state in an S3 bucket or a GCS bucket or an Azure Key Blob storage, there's like a whole host of different things that you can actually store your state in. But at that point, it's really important to say that it is only the state that gets stored in the bucket. We don't store credentials unless you hard code them as part of your application, and Pulumi doesn't understand that they're credentials. There is no connectivity between the SaaS or the S3 bucket and your cloud of choice. It is just a simple bucket for storing your state of your infrastructure applications. And then just one very last point before we get into demos in how Pulumi systems are broken down is you usually have an organization, or if you're in the open source backend, you don't have an org, but you have a project, and a project can be for a specific part of your infrastructure, like your VPC or your Kubernetes cluster or your service for user profile, your service for email. And then inside each project, you would have an individual stack. A stack being a representation of a specific set of those resources. If you think of it as terms of an environment, so maybe a dev environment or a testing environment or a production environment, or it can be every individual developer can have their own stack as well. So stacks can be revved independently of each other. They can be created, they can be destroyed independently of each other, and they can have completely different configuration values from each other. So let's actually go and write some code so that we can actually see what's going on here. Now, Pulumi is a CLI app, and if I run the command Pulumi, it will tell me, it will give me some information about what it needs to do. So it's like, if you want to start with Pulumi, run the Pulumi new command. The most common commands are up, stack, config, and destroy. But of course, there are other commands that are available with this. So let's create our first demo. And let's run the command Pulumi new and see what happens. So Pulumi new will actually start to scaffold a new Pulumi application for us. And it will be able to tell us all of the existing templates that are available. And today I'm going to choose AWS TypeScript because I find that TypeScript works extremely well for infrastructure management. Okay, so it will ask for a project name. So we give it a name, you can give it a description if you want, and then it'll ask you for a stack. Okay, now a stack, as we said, is we're just going to say dev stack, just to make the default. And because it's in AWS, it will ask us like an extra question of where do you want to deploy this into? Okay, so we're just going to say US West 2. And then, of course, as it's TypeScript and JavaScript, it's just going to install the entire internet, which should all be quite fast. And at that point, we actually have an application. Now I have an IDE open here, and I want to show you what it actually looks like. So the first thing that it does is it creates the scaffold of the application and installs all of the dependencies that you need. So we have all of our node modules that it installed, and that's based on the package.json file and the package lock file that goes with it. Okay. After that, it creates a Pulumi.yaml file, which actually suggests about the name of the project, the runtime. So every Pulumi application has a specific runtime, and you can't just interchangeably write Go with Python. You would have a Go application, you would have a Python application, a TypeScript application, and a .NET or a C#. And so you actually have a very specific like encapsulation of the application here. Then you have tsconfig, because this is like TypeScript. And more interestingly, it creates a pulumi.stack.yaml. In this case, it's a dev.yaml. So we can see that we set it to be US West 2. And then lastly, it creates an index.ts. And this is the most basic representation of a Pulumi application. And there are three parts to what it actually shows here. So the first part is that we create some helpers. So the helpers being the import libraries. So we actually have access to the Pulumi libraries. We have access to the AWS libraries. And then lastly, we have access to AWS X, which is what's called Crosswalk. And we'll show you Crosswalk in a little bit. Then we declare resources. And you can actually see its namespace as AWS being the top level entry dot submodule dot resource. Now we can, of course, step into resource, and we can see that a resource, a constructor takes a name, it takes some arguments, and it takes some options. Now this is, as you can see, this is what a typical developer would do normally. They have an API that they write code against. And then lastly, we export some constants if we actually need to. Now here it's going to create an S3 bucket and not do anything else that it needs to do. So what we can do is we can run the command Pulumi up. And Pulumi up will now start to be able to tell us what it's going to do. So the first thing it's going to do is it's going to say it's going to create a stack. And then based on the stack, it is going to create an S3 bucket. And it will give us an output of everything that it's actually going to do. And we can see the details of, you know, the ACL, the bucket name, force destroy, and so on and so forth. So we can say yes, and we can roll that out. Now, after that, what we can actually do is we can start like write some like extra code in here. So we can say tags for the bucket, and the tags need to have an owner, excuse me. And the owner would be stack72. I've not had enough coffee yet. And we can see it created the bucket. Now, as I told you, it's an idempotent operation. So it should only change what needs to change. In this case, we've added a new parameter called tags. And our preview of what it's going to do is going to tell us that, yes, the only thing that it's going to change as part of our infrastructure here is tags. And we can roll that out. And I will just let that finish a second. It should not take much longer. There we go. Okay. Now, it's important to say that I have a lot of S3 buckets as part of this AWS account. You can see a lot of them are all testing buckets. But when I run the command Pulumi destroy, it will tell me that the only thing that's going to destroy in this case is my specific bucket, because it has state about that application. And if I go back and I run AWS S3, you will still see all of the same buckets, like all the URL shorteners and stuff like that. So it is very much a targeted destroy based on your application architecture. Okay, cool. So let's go and write some better code, some code that is actually useful for everyone. that they can take away today, and you can show how you can develop and refactor an application as you go. So I'm going to scaffold a Pulumi new AWS TypeScript application, again, as before, and I'm going to call it 4Developers Demo 2. And I'm going to, again, do US West 2. Now, I have written a lot of this code already, so I want to just copy and paste this. You'll have to forgive me. It's not the best JavaScript in the world, but it is very, I'm going to call it fun. You know, it will get the job done. And there we go. We have demo 2 right here. Oh, excuse me. And we can actually save this. So the first thing that we are actually doing here is we're going off. We're making a call to AWS to get a specific AMI. AMIs are used in order to build machines. Next thing we do is we create a key pair. Please never do this. This key pair does not exist other than a demo. So, and you can even see the comment is email@example.com. You just never embed your SSH keys as part of what's going on, but for demo purposes, this is perfectly acceptable. We create a security group that is wide open to the world, and we create an EC2 instance based on it. Now, notice that we're actually using like enums as part of our Pulumi code, but very much I could create a T2 small as part of that in order to show it. So the application will take anything that you require it to take. Now we have type checking into it. So EC2 have instance types, RDS have instance types, lots of different things in AWS have instance types. And if I use the wrong one by default, we of course get, you know, that IDE based outputs to tell us that this is not the correct type. So, you know, we're continually getting all of the correct information that's going on in here. So what happens? This just rolls out a single application, or excuse me, a single EC2 instance. What happens if I want to, like, you know, roll out 50? I need like a lot of different infrastructure. So let's refactor it. So let web servers equals an empty unbounded array. I love JavaScript for this. I hate it for lots of other things, but in infrastructure, it's fantastic. And then we can actually say, let I equals 0. I is less than, let's just say 50, not 150. And we can say I plus plus. Now, of course, for those of us who are programmers, this knows that this is the most basic thing that you can actually create, which is a simple for loop. And then based on the for loop, we can actually web servers dot push. So we can push items into our array, and it would be a new aws.ec2.instance. Every resource in Pulumi needs its own individual unique name. So what we actually have to do is we can say web dash server dash, and then we could just grab the index of I so that we can actually add things on. Based on that, we can copy our parameters. And we are adding 50 items to the loops, out to the loop. Now, in this point, of course, web server no longer exists, so we actually need to pull some information out of there. And we can actually say web servers dot map, and we can just have a very small lambda that just grabs all of the pieces of information, like the public DNS out of it. Now, of course, we've just been able to go from 1 instance to 50 instances in like very short amounts of code. And we could even start to extend that a little further. So let's pretend that we don't actually care about what happens in the inside of this. What we actually want to do is we want to create a web server class. Now, I can pull in some information, like the user doesn't care about a key pair, a security group. So let's take that out. Let's put that inside our web server class. And then you can see that my ID has already brought in my imports that it requires as part of this. And we can actually refactor this as we go. So the first thing I'm going to do is I am going to export a class. And I've lost my mouse. There we go. So I'm going to say, let's export class. and the class will be called web server. And that class, we wanted to return an instance of a VM. So let's say public read-only VM, which is a type aws.ec2.instance. Now, at that point, we have a class which has a return for us. So now we can actually create a constructor. So our constructor will take a name, which will be string. It'll take an AMI ID, which will be string. And then lastly, it will take an instance type. And the instance type will be aws.ec2.instance type. Now we have our constructor, and we can actually start to build all of the pieces that we require. So we can say this VM equals new aws.ec2.instance, and the instance will actually, in this case, name, and then which will have an AMI. It will take a key name, excuse me, and it will take our SSH key, .key name. We can have our security groups, VPC security group IDs, I apologize, which is a list, and we can actually say open security group .id. And then we can actually give it some tags, the default tags that actually go there, and we can say owner, and then we can say demo. So at that point, we actually have, one more piece. We actually have to give it an instance type. Why do you not instance type? And our instance type will be the instance type that we passed in. Now, that's why I duplicated some information. So at that point, we actually have a web server class. And then based on the web server class, we no longer need to push a new EC2 instance into the stack. We actually say a new web server. Now notice straight away, as soon as I do this, my IDE will bring in all of the pieces that it requires. So right here, import web server from web server. And we actually need to give it a name. The name here will be web server -$i. And then we also need to give it a few other pieces. So the other pieces that we require is an AMI ID and an instance type. I'm actually just going to pull this AMI ID out again. And let's put that back here. So the AMI ID is what we're passing in, which will be ubuntu.id. And then lastly, an instance type, when we can say aws.ec2.instance types. And we can say T2 small. Now at that point, we actually see, wait a minute, there's something here. There's the type of output is not assignable to string. So Pulumi works on promises, and outputs are not resolvable at preview time. They're only resolvable at runtime. So they need to be passed around as output values. And then internally, Pulumi changes what's going on. So we go back to our web server class, and instead of our AMI going in as a string, what it actually needs to do is it needs to go in as a Pulumi.output of string. Now notice that nothing inside the code actually changes, just the method signature, or the value that's passed in the constructor, should I say. And at that point, we actually have a fully working class. And notice lastly that we're getting full IDE support saying public DNS no longer exists on our web servers map, because web servers don't return an EC2 instance type. They return a VM, which is of type EC2 instance type. So we need to say VM.public DNS. And at that point, we've got a fully working, fully refactored application. So let's go and have a look at something very fast as well. And let's actually see how you would run some acceptance testing, or excuse me, some unit testing. So let me just open my IDE here. And we have some code that looks like this. So we have a security group, and based on the security group, we create an EC2 instance. It has some details as part of the instance. How would we actually test this? So the first thing that we do is, let's come back to the Pulumi mocks. We can actually write like Mocha style testing, try a Mocha style testing to actually describe our infrastructure. So we describe the server. The server must have a name tag. If it doesn't have a name tag, we throw an error. It must not have user data, using AMI instead, otherwise it'll throw an error. And then lastly, we do a check on our EC2 security group, and it must not do things like open port 22 to the world. It needs to have specific details. Now notice here that we're able to loop through all of the pieces of the group. So we're actually able to get the exports from this infrastructure class into our unit testing class, and then based on that, we're able to look at each of the individual parameters and actually write specific rules against this. Now, of course, because of that, we actually don't want to call AWS in any way, shape, or form. So Pulumi has this idea of mocks built into it, where you can mock a new resource. So that's a call to the creation, the update, the deletion of an infrastructure application, and then you can actually have specific returns for each of the types that you're actually trying to do. If you need to do something differently with instances from security groups, you could build that into your mock. Otherwise, you could just like have a default and that just returns through. And then lastly, we have a mock for a call, which is a data source, which actually is trying to get infrastructure already existing in the cloud so that you can use that and ingest that as part of your application as well. And if I go back to my code, what I will actually see here is, firstly, it's important for me to say, look, grep AWS access key. There is no AWS access keys on my machine in this terminal session. And because of that, I can say mocha -r ts node, which is a dependency here, register. So we're just actually calling into registration, and then we can say EC2 tests.ts. It's going to compile our application. And as soon as it compiles the application, you can see that it actually runs those tests in 7 milliseconds. Now, it definitely does not take 7 milliseconds to deploy an instance in the cloud. It is a much slower operation. It's maybe 2 or 3 minutes. And of course, being able to run your infrastructure tests in 7 milliseconds compared to minutes is a much faster turnaround as part of it. And then lastly, we can show you how we're trying to bring what the developers are doing as part of infrastructure. So this actually application, this does a lot of different things right here. So the first thing it does is it deploys a DynamoDB table in AWS. After it creates a DynamoDB table in AWS, then it creates what's called an AWS X API gateway. And this is a wrapper function that means you don't need to know all of the different pieces to deploy some functionality in the cloud. So what this does is this will actually, the API gateway will give you a collection of routes. And on each route, you can actually say what the method type is, and you can give it an event handler. And this will actually pull all of this information out right here. And Pulumi will understand that all of this code inside this async event handler is actually code that needs to be deployed as a Lambda. It will package that code up. It will deploy it as a Lambda. It will then create the API gateway and the individual specific route for that API gateway. And it will associate the Lambda that has been packaged with that API gateway route. And it will allow you to, it will pull in all of the dependencies that it requires. So we can see that here we're talking directly to the AWS SDK from inside our Lambda. And as part of our application import, we don't have anywhere around the AWS SDK, but Pulumi understands that that is a dependency, and it will pull that out, and it will actually package that up and deploy it. And lastly, it will give you an export of a URL that comes back off the back of this. So it's extremely powerful in what it can do, and it has a lot of use cases in order to drive things forward. But I just wanted to go back to how we're able to abstract away information that people actually don't need to care about. So if I go back to my demo1 folder, and I want to show you that in order to create an AWS VPC, what you actually need to do is you would need to do const VPC equals new aws.ec2.vpc, and you'd have some parameters. And then off that, you'd say const subnet1 equals new aws.ec2.subnet. And the subnet would take a VPC ID, and you would need to give it some CIDR math because you need to give it a CIDR block and all this different stuff. And it's already starting to get difficult for a developer or people who don't really care about networking operations in order to get going. So this is where we create a crosswalk equals new AWS X. So X being for crosswalk, .ec2.vpc. And I'm going to say my demo VPC. And I'm going to give it some empty arguments and nothing else for now. When I go back to my terminal, if I run Pulumi up, then what you will actually see is Pulumi will create, or it will tell me it's going to create 31 resources as for that VPC. And you'll see them in a second. And you'll see it has all the subnets, the route tables, the route table associations, the routes, the NAT gateways, the elastic IPs, and the internet gateway that goes with all the different pieces. We're going to say no, but of course we can customize it. We can actually say CIDR block. On the CIDR block, let's say 10.10.0.16, and let's say we need to enable classic link for our DNS, and we enable host names, true, and then subnets are like a list of subnets. The first thing we need to do is we can say that we want just private subnets, and the CIDR mask on those private subnets. You can start to see that as you need to build up and you get more understanding of how the VPC works, you could start to be a little more descriptive in what's actually happening inside your VPC. And then lastly, I can say number of NAT gateway, actually number of availability zones. We're going to say 3, and we're going to say number of NAT gateways 1. Pulumi will handle all of that as part of it. And if I go back and run Pulumi up again, we'll actually see a different number of resources now. It won't just be 31 anymore. It will tell us that it's going to create 17 resources because it doesn't need to deal with any of the public subnets. It doesn't need to deal with any NAT gateways and all these different pieces that's going on in here. And we can start to be a little more explicit as actually what's going on in there. So that's a whirlwind of Pulumi. We really believe that Pulumi is starting to be the easiest way to program the cloud. It's no longer just a declarative syntax. It actually allows you to take advantage of all of the programming constructs that you require. And I thank you for your time. As I said, I'm Stack72 on the internet if you have any questions, and I'm going to pass it over to the studio and see if anybody has any questions for me.